exciting. Hi, nice to meet you all. I'm Stuart. I'm the Appsec Program Manager at Access Group, one of the largest ISVs in the country. In fact, depending on who you talk to, sales the largest ISV in the country. Most of us, this is going to be a slide-based presentation. It's not going to be interactive, so apologies for that in advance. I've tried to keep it brief and keep the slides with about 15, 20 different pieces of text on there. Stop me at any point if you want to ask any questions. I have a tendency to speak really, really quickly. I'm a product of my London upbringing. So if anything's not clear, or if you want me to go back and repeat something, just give me a shout, let me know. Questions and answers at the end as well, if anything that I say is interesting enough to you, or you just want to have a question. So I've titled this, How I Learned to Stop Worrying About Everything and Start Worrying About Everything Else, which is pretty much my job in Appsec. We're a huge organisation. We've got something like 220, 230 products, and then slice and dice it across 12, potentially 13 or 14 divisions each. Every single application we have has its own security challenges. We're an acquisitive organisation. We buy a lot of companies. Every company we purchase comes with its own security culture, some better than others. So I thought what I'd do is give you an idea of how we handled Appsec, give you a quick overview of what Appsec is and how it differs from InfoSec, how we handle it in business, some of the tooling that we use, and most importantly, what we do to try and shift left. I hate that term, but the industry hasn't come up with anything better yet. So what we try to do to make security, to embed security in everything we do in the development process, rather than fixing problems later down the line. So just a little bit about me. I've been in the role nearly 3 years now. No, nearly 2 years, all right. Depending on what day of the week you catch me, I'm older than I look or younger than I look. I've been doing this job in various forms for a long time, nearly 20 years. I'm responsible for our Security First program. So what that is a program that allows us to embed security in everything we do, but also validate what we do in the development process and validate what we've got out in the world. So as I said, I've got many, many years of experience. I started out on the coalface. I'm one of those rare people that didn't start in support, so I started out as a DBA for my sins. Quickly decided that I did not want to do that for a living. Apologies to any DBAs here or people who come from that route. But security was always something that interested me. I started out fiddling with things a long time ago. Like probably most of you in the room, I did some stuff that wasn't what you would call technically legal. I bent a few laws. I don't think I fractured in it. And found myself sort of gravitating towards security at a pretty early stage of my career. I worked for Fujitsu. Apologies. Very briefly, I might add, in their firewall team. I worked for a police force, so a national police, the only national police force, British Transport Police, as their IT security everything at the time. So that was ops and dev, everything. And then moved into commercial real estate. Not actually in commercial real estate, but supporting a commercial real estate organisation. And from there, moved to Lucas, car industry. The hardest, most challenging environment you will ever work in for app security. You wouldn't think so, but every single car manufacturer has their own way of doing things, and the vast majority of them, their approach is to just outsource it to you. But they provide you with very little information, so there's a huge amount of information gathering and discovery going on all the time, and your responsibilities are extremely important, but they take out all of their responsibility themselves. So it's a challenging environment to work with. But it stood me up in good stead for the role that I've got now. So in the last 10 years, I've moved more towards the program management space, so away from the coalface. At Lookers, it was entirely away from the coalface. That bored me, so I'm now sort of like toe in both camps. So I do some tooling and some engineering and also some programming. So as I said, 2 years into the role at the Access Group, they decided about 2.5 years ago that they needed an Appsec function. It was something discrete from InfoSec. At the time, it was everything across the board was all done by the IT security team. So there's me and another guy called Kane who joined a month after me. So Kane is extremely experienced as well, slightly more technical than me. So the two of us are responsible for, as I said, 230 products, something like 2,000 developers between two of us. So you'll see the challenges involved there if you play that over in your head. And I'll come on to some of the stuff that we're doing to try and make that a bit more streamlined and make it manageable for us. And in my spare time, I race bikes. That's pretty much all I do. Appsec and most bites. I've got all the scars to prove it: broken teeth, missing teeth, broken wrists, broken legs, etc. So I like risk in my job, and I like risk in my private life. Have I what? One that race against the bike. No, but I did face one on the East Lancs Road, if I had, hence the missing teeth. So, I thought I'd just give you a quick overview of what I'm going to cover. I'll try and keep as much of the stuff brief as I can, because I've got a different I could talk about this for hours, even though I speak quickly. So what is Appsec? How do we manage it at the Access Group? So basically breaking it down into the two domains that I spoke about earlier, so shift left and current stuff. What do I mean by shift left? So you've probably heard that. It's sort of a buzz term in the industry and has been for a while, but what does it actually mean? And more importantly, how does it physically work for us? And then tying it all together at the end. So how we try and maintain an overview of everything that we've got, try and sort out the real risks from the potential risks from the fake risks. There are plenty of those. Hence, as I said, how I learned to stop worrying about everything and start worrying about everything else. And just basically giving you an idea of what it's like for us to manage an organisation at scale. So if you ever end up in an Appsec function somewhere, hopefully you'll take something away from this and realise the challenges, how we can support developers and how we need developers to support us. And then at the end, Q&A. So any questions that you've got, hopefully I'll be able to answer them. As I said, I'm reasonably technical, so if you've got technical questions, I should be able to field them, especially when we're talking about tooling, compromises, etc. But I'm also boring as well, so I talk about a lot of risk stuff in my job. So if you've got anything related to that, I very much doubt you will. But if you've got anything related to risk, I'll be able to answer those questions. So, Appsec. Apologies in advance as well. I'm blue-green colourblind, so your colours might look a bit weird. They look fine to me, but they might look fine to you. I've gone through this and had it seen by somebody else, and nobody's made any comments, so it should be okay. You're not likely to get a graph with 16 different variations of the colour yellow. So, what is Appsec? The security of applications, right? But the reason I put this slide in and talk about it is because there's a distinct difference between Appsec and what people traditionally think of as IT security. So, generally we call that InfoSec or IT. So, it's not NetSec or InfoSec. You'll get bundled in with it quite a lot. We find that most people we speak to in the IT industry as a whole don't really get the difference between the two. But what we're focused on specifically is the security of the application. So the frameworks that the applications use that are used in the application to develop it, the technologies that we use to support it, so full stack development, things around DevOps processes, etc., so deployments, threat modelling at an early stage to try and get an idea of what an application looks like and where your key risks might lie. So it's a little bit more, what's the word? It's slightly amorphous compared to ITSec, which tends to be firewalls, IPSs, network devices, that kind of thing. So it deals with developing, releasing and maintaining secure software. So at its heart, the shift left thing is the most important thing for Appsec. So pen tests, bug bounties, application security checking tools, they're all great and they help give you a feel for how secure your applications are when they're out in the wild. But there's no substitute for developing securely at its outset. So it's embedding security practices into developers from an early stage development. So threat modeling to see if the application design itself is secure. When you're talking about things like secrets management, not leaving passwords and keys knocking around in applications or out in GitHub for someone to find. Using secure coding practices so you prevent input, so you sanitize your inputs, that kind of thing. It's relatively new compared to traditional ITSec. I mean, ITSec's been around 25, 30 years, really. This is quite a new field, so there's always been, since SaaS applications became more of a thing in 2010s, late 2000s, became more of a thing and more widespread and ubiquitous as opposed to sort of client-server model applications. There's always been a realisation that there is a risk in that model, but it's never, until the last 5-6 years, it's not really been broken out into its own separate domain. But you'll find now the vast majority of organisations, especially anyone that operates at scale, have an Appsec function, which is good. keeps me in the job. And it also means that people aren't focused primarily on network devices and servers and infrastructure like they were, and letting all sorts of nasty things happen to your applications. So, how do we implement it? So, two main concepts. Technically, you can say shift left is first and then in-flight security is second, but I thought because I wanted to give you a flavour for what we do when in our day-to-day job, I'd go with the in-flight security first. So that's basically what we've already got. So currently deployed software, I'll go through some of the security tooling we use. Some you'll be familiar with, some you might not be familiar with, or not as familiar with, and then penetration testing and bug bounty as well. So this is everything that we've already got that's out in the wild. So as I say, we inherit applications from companies that we buy. We find when we lift rocks that there are a lot of other applications hiding that weren't tested in the due diligence part of the purchase, for instance. So I'll give you an example. We purchased a company, I think due diligence completed 4 months ago. We just started pen testing their primary offering, which we tested in due diligence as well. And when we lifted that rock, we found 7 other applications. So we've now got to find a way and a schedule to test 7 applications in 3 months. Pen tests will be very familiar with that because we lean on them quite heavily for our pen test services. And then security by design. So more on this in part 2. And this is the more the interesting stuff, if you like, because this is the slightly more ephemeral things. So we're talking about design, as I mentioned, and practices to make applications secure so that you get rid of those, I'd say bugs, probably the best way to use it. Get rid of the bugs in the development process before the release. So shift left approach, I'll cover our secure development lifecycle, SSDLC, and touch very briefly on threat modeling. I'll go through a slide on threat modeling, but I won't go through it in any depth because we could talk about that for hours on its own, and it's a very dry, boring subject. But we do threat modeling. So, am I talking too quickly, or is everything okay?
Just before you start, what languages are you generally dealing with?
Absolutely everything. So every acquisition. So we're primarily a .NET house, but every application, every company we buy brings their own dev stack. So we've got LAMP, .NET, C#, React, everything you can imagine, including some old Colbo lying around. That's interesting to everybody. So yeah, every single dev technology stack you can think of, we've got it. So some of the tooling we use. SCA, so software composition analysis. Most of you will probably be familiar with this. So you'll be familiar with the fact that most modern applications make use of third-party libraries, dependencies, etc. So we're no exception to that. In the 230 applications we've got something like, depending on what Mend reports from one day to the next, something like 32 to 35,000 different items. So you can imagine trying to keep on top of that. It's an impossible task for one person to do, simply using the Mend software and the SCA platform that we use. I'll come on to what we use to try and sort the wheat from the chaff a little bit later. You'll see there's a familiar theme here. But SCA, just keeping on top of library vulnerabilities alone is a massive task. And obviously we don't only use it to keep on top of library vulnerabilities, we use it to keep on top of licensing as well. Because not every open source license is created equal. So some licenses are very permissive, you can basically do whatever you want. Some are extremely non-permissive. So AGPL3 is a perfectly good example. That can leave you open to all sorts of inquiries from lawyers. Google found that out relatively recently. Keeping on top of the licensing is just as important as keeping on top of the security vulnerabilities. So it deals, as I said, with maintaining those libraries. So the platform we use is called Mend, it used to be called White Source. For relatively obvious reasons, they changed the name because that is a particularly good name to be using in this day and age. So they changed it to Mend. There are competing offerings out there. Sneak is a very popular one. A lot of places use Sneak. Mend is on a par with Sneak. Sneak has some better functions for things like SaaS, so secure application software testing. Mend doesn't do that, or it does do it, but it doesn't do it very well. But we use Mend. We're quite happy with it. The interface isn't particularly good, very old looking. and the reporting is extremely clunky. So trying to get some usable information out there for reporting purposes, for board level, etc., is very challenging. But on the technical side of things, it does a really good job. So supply chain risk is one of the biggest headaches for any organisation. You'll all be aware of the recent Zealous hack, I'm sure, which was related to a third-party component they used to move files around within the application. That's our biggest nightmare. So third-party components used in an application that we don't control and can't secure. So it's one of our biggest headaches, and these SCA is absolutely essential for us. So how do you keep on top of the endless list of vulnerabilities? So how do you tell the next log for J from the next puny code? Not bad. A complete waste of everyone's effort and time. It's difficult to do that. It's impossible to do it without a large aggregating platform for that information. Mend allows us to sort the wheat from the chaff, if you like. Mend does a really good job of updating vulnerabilities, so as a vulnerability is disclosed, it may be given CVE, CVSS at the specific score, and then later down the line, it may well be exploitable, before it wasn't when the CVSS changes. I've seen plenty of SCA platforms that don't update or don't update in a timely fashion. Mend does that very quickly. So as I say, on the broad technicals of the tool, Mend works really well. So we include SCA in our pipelines for our modern stack apps. So anything that we deploy regularly and is built around a good DevOps process, we can include Mend. We have the ability to fail builds, etc., if the dependencies need to be updated, and if there's an update available around an unupdated version. Where it struggles, along with every other SCA platform, is transient dependencies. So that dependencies where you're not actually depending on a library, but that library is dependent on something else you don't control. Every SCA platform struggles with that, and there's not really a realistic, valid way to do it to keep on top of that, other than doing it manually. So, moving on to tooling. Something called SaaS. Sorry, go on.
So what do you use the package distribution to that? Package distribution, special stuff like that. How do you do your open source package distribution? From NPM?
It depends on what they're using. So NPM generally it depends on the frameworks that they're using. Yeah. So we're not, obviously, because we don't only use one, we don't have the luxury of being able to say, right, we embed it in this and every DevOps process uses it. Because they'll use different processes and package managers themselves.
So you're still using their public repositories?
Most of the time, not always. Yeah. So occasionally we've got private repos that we use for specific things, but generally speaking, yeah, we use a public repo. No worries.
Do you do anything like Dependabot where you've got something that runs repeatedly that's not on the pipelines?
Yeah, so some teams do. It tends to be teams where we've got a modern stack app, so it's been developed around a good DevOps process. It tends to be stuff that's entirely SaaS based, so didn't come from a desktop app to start with and then get SaaS afterwards, or something that's been developed maybe in the last 4 or 5 years. So we do have a lot of other stuff where we just can't do that because we've got code bases that don't support it, the way it's hosted doesn't support it. But yes, wherever we can, we try to. So we try, but we don't. It's interesting being an organisation this size. It's impossible to mandate things on developers. So I come from the InfraSec background originally, and I've come from that adversarial relationship where you're seen as the bloke who sits in the corner and says no, and that doesn't work with developers. It just doesn't. So we try to be as loose as we can, as laissez-faire as we can, whilst managing and controlling the risks around the development process that the team might not be as aware of themselves. Nobody wants to be in an adversarial relationship anymore. I'm sure there are still plenty of firewall teams who sit there and get off on being nasty to people. That's not me, and it's not the guy I work with. Anything else? So, conscious of the fact that we've got 45 minutes, is it? Before the pieces get the most important. So the next tool that we use is something called SaaS, so Static App Security Testing. As I said, Sneak does a reasonably good job of this, but because we're a Mend house for SCA, we don't use it. We use a product called SonarQube, which is pretty good. Developers have their own opinions of it. Some developers love it, some developers hate it. I will say from a management perspective, it's a pain to manage. It doesn't have a nice user interface. Again, along with Mend, the reporting support, manageability and control of security for individual teams is tedious process. As I said, there's a recurring theme here. But it does do a really good job technically of analysing code. So most important for us is, I'll come on to something that we use afterwards to try and tie everything together. Most important for us is using a best-in-class tool that does the technical aspects of what we need to do well. So designed to analyse source code for common risks. So things like SQL injection, cross-site scripting, hard-coded passwords, secrets, that kind of thing. So stuff that should be bread and butter to most developers, but is especially challenging for older applications where we've inherited an application and the dev process weren't particularly good, or it's so old that people just didn't realise it was a problem when it was coded. We've got plenty of that as well. SonarQube does a really good job of that. So cross-site scripting is a really good example. So where we've got areas of applications that don't sanitize input properly, we do have a lot of applications where we can't prevent people from inputting special characters, for instance. So we've got a lot of software that acts as kind of a CMS or wraps around a CMS, and allowing people the functionality to input their own code is paramount, so we can't just stop it. SonarQube does a really good job of seeing that and seeing where it might be an issue. We generally tend to find with cross-site scripting, along with SQL injection, where we've got an issue in an application, and we've got more than one or two instances of it, it's endemic throughout the application. So if you think of an application that's got 6 or 7 different modules, got its own login and auth process, uses 4 or 5 different technologies, front end and back end, it's been upgraded from one database platform to another, and then made SaaS from an on-prem product. Imagine trying to find every instance of that with a pen tester. So I'm sure pen tests in the room will be rubbing their hands with glee, thinking about how many days they could get out of the original pen test budget for that. Best will in the world, guys. I'd love to give you 35 days to go through an application at length, but budgets just won't allow it. SonarQube is really good for that, because if we can find an endemic instance in an issue in an application, and we fire SonarQube at it, it generally does a really good job of finding other areas, fixing those, and then potentially getting a pen test company to validate that in a test, specific focus test. Used properly, it allows developers to code quickly, then review prior to release. So this is really good. If we've got teams that are under the gun for a release, it allows them to go through and potentially, not say ignore, but not take massive account of a potential issue when they're coding. Smash through the code, get it reviewed, and then push it through SonarQube. If it finds 2 or 3 issues, the developer might say, right, I'll go back and have a look at this. It's really good for that kind of thing. So, like every other software house, we're constantly under pressure to release, especially when we're talking about features rather than against vulnerabilities. So it's really good for that, really useful. I'm conscious I've said SonarQube here and Mend. All of the SaaS platforms or SCA platforms, they'll all do this. It's just we choose one that works well for us. So other platforms are available. It isn't perfect. So this is where it's a pain for me and pain who I work with. It generates an enormous amount of false positives. If you think about what it's trying to do, basically it's trying to interpret the code and think where there might be an issue. Now, for SQL injection, for instance, that's generally relatively straightforward. So non-parameterized queries, you're all familiar with SQL injection. Okay. So non-parameterized queries are pretty easy to pull out of code. Cross-site scripting, yes and no. It's really good at certain elements of it, but not particularly good when it's something that's quite obscure. Functional level access control, so business logic, no chance. There are modules and there are parts of SaaS that allow you to do that, but in reality it's just guessing. Eventually AI, such a buzzword, but eventually AI, as it's generative and it learns, it will make a massive dent in that problem, but it ain't there yet. So it generates a huge number of false positives, and until we implemented, I'm conscious that I keep teasing this, but until we implemented what we used to manage everything at the 500-foot level, it was impossible for us to get to the top of it, and developers didn't use it as a result, because every time they fired their code for it, they were getting 50 issues and 2 of them were legit and 48 weren't. So it generates a lot of false positives and it isn't perfect. As I said though, it can be very useful in finding issues. Other instances of an issue you find in a pen test or anywhere else. So where you find SQL injection in one part of code, you're likely to find it somewhere else. CSPM, I love this. Because somebody thought it was a good idea to let devs spin up their own infrastructure. So as I said, coming from that sort of no background that I was originally. I was infinitely familiar with this problem. We call it shadow IT in ITsec. So it's basically where you allow developers or anybody else the ability to spin up their own infrastructure. So I was around when VMware was first a thing, so when virtualization was first a thing in the industry, and it was demoed to me in HP's headquarters in London, and I was blown away when I saw it. When somebody showed me vMotion for the first time and I saw 3 ping drops, I almost fell off my seat. It was incredible. But almost at the same time I thought, Jesus, if we give this to developers, what a nightmare it would be. They'd be able to spin up their own stuff and we can't control it. And lo and behold, within 6 months, that's exactly what happened. Every business we acquire has some form of a web presence. The vast majority of them are, sorry Amazon, Azure, but we've got quite a lot of AWS as well, so I think I'll probably get away with that. And every business we acquire allows a developer to spin up their own stuff. You can imagine trying to keep on top of that. It's a nightmare, not just for us in Appsec, but also for InfraSec as well. So we inherit companies and all of a sudden they inherit 60 new servers. There's nothing there. So CSPM, Cloud Security Posture Management, that acronym will change. It changes about once every 6 months. That's what it's known as at the moment. Analyzes cloud tenants for common misconfigurations. So things like spinning up a VM and allowing access to the outside world without a firewall. At its base instance, there are hundreds of other security groups not being provisioned correctly, SQL DBs that open to everybody, that kind of stuff. When I said that SaaS generates a lot of false positives, you could not possibly imagine orders of magnitude larger for CSPM. We're a Palo Alto house for firewalls, so we use Prisma, which is their CSPM offering. Again, like other apps, it's poor at reporting, and also it generates a huge amount of false positives, probably even more than SonarQube. When you think about what it's trying to do, it's trying to interpret a rule that says, for instance, don't allow unfettered access to the outside world. Well, that's fine if you've got resource, but if you're talking about an S3 bucket and you want it to be public access for whatever reason, it cannot tell you the difference. It does a half-assed job of telling you the difference. So it generates a huge number of false positives. It's very important for containerized apps. So we've got a lot of stuff that uses Kubernetes and Docker, where we've got instances that have been spun up, and then reference instances aren't updated. And then every time we deploy or we scale out, we develop, oh good, there's another 15 instances of the same issue. Prisma or Palo Alto bought a company called Twistlock, which does containerized scanning as well. So we recently acquired another company, I'm not giving away any trade secrets here, I think. We recently acquired another company that's in the hospitality industry, and their security was fantastic. They had great DevOps processes, but their containerized security was non-existent. So every time they were scaling out, they were getting a whole load of new issues. They didn't have CSPM hack to fire at either, so they were getting a whole load of new issues every time they scaled out. And instead of fixing those root issues, which they should have done, they were triaging and fixing on a case-by-case basis. So if you think you've got 20 instances you spin up every time you scale out, you get 20 another set of 20 warnings, and then instead of fixing the problem to stop that happening, you keep fixing those instances. Just imagine how time conditioning now. It's not as well as this. It's not fire alarm, is it? No. Good. So as I said, it requires a lot of tuning, and every application has its only tuning requirements as well. So it's not just you can say, right, okay, we know this rule is an issue, so across the 180 apps that we've got in Azure, for instance, we can just turn that rule off. Because every application is different. Some apps might require that, some apps won't, some apps might require something in between. So it requires a lot of tuning of that to be useful to you. So it's not just generating a load of noise. It's very difficult to prioritize alerts. As I said, differences in cloud environments mean that something that's a red alert in one cloud environment literally might not be an issue in another. Textbook example of that is a WAF, where we've got a WAF in place to sanitize user inputs. We use WAFs for almost everywhere. We use WAFs for load balancing, DNS, etc. But we've got very few environments, annoyingly, that don't use it to sanitize inputs. But where we do, obviously, a red alert for something that comes up in CSPM for an application that doesn't have a WAF isn't the same. If you've got a WAF in front of it, Yes, you need to fix the underlying problem, but provided you're confident your WAF does what it says it does, we use Cloudflare, then I'd downgrade that alert. What you tend to find is you're basically running around shouting fire, fire all the time and not understanding where your actual risk lies. So CSPM is really a real pain for that. But it's an interesting area to work in because you're constantly dealing with developers. And as I said, trying to move away from that adversarial, you can't do that, you shouldn't do that relationship, into one that's like, okay, I can see why you've done this, but let me tell you why you shouldn't, and this is what you can do to prevent it. It's really good because every time you have that interaction with a developer, you're giving them more information, more knowledge. And then coming on to testing. So away from the cold face, so testing, pen testing. So traditional pen testing, because it's better than marking your own homework. We do a lot of internal testing of our applications. We've got quite a lot of teams with good QAs, and their DevOps processes tease out quite a lot of issues. But there's no substitute for getting somebody who's good and whose job it is to break an application to break your application. So we do a huge amount of testing. Think between our primary pen test partner, we have an in-house tester who's independent and not part of the organisation, so we get that sort of CREST-approved independent verification, but we manage their time. We've got a third party as well where we use, I'll come onto a tool called Appsec later for gas. We also use their service for some type of pen testing. But at any one time, we've got somewhere between 3 and 6 pen tests going on. I manage that. It's a hell of a job. I've been doing it for 15 years in various forms, but it's 10 times larger than any pen test program I've ever managed anywhere else. So at any one time, 3 to 5 tests going on. We do around 220, 230 tests a year. And that grows every year with every acquisition. So independently verified pen tests. Hands up how many of you do this without being paid to do it. You'll know what I mean. Don't be shy. I know there are some pen testers here somewhere. No? So that goes back to the old fracturing the occasional law or bending the occasional law. So a lot of people act as independent security researchers, and that's brilliant. I'll come on to bug bounty in a minute. But there is no substitute for getting somebody independently verified to mark your own one, if you like. And in a lot of our applications, we operate in the healthcare industry, for instance, it's mandatory. So it's a requirement, legal requirement for us to test it every year. Also the education sector. So the education sector and the healthcare sector generally tend to be really stringent around their testing requirements. No automated tooling can replace the experience and intuition of a skilled researcher. I can't stress that enough. All the tooling we've got in the world is fantastic, and as AI grows, it will get better. It will never replace a tester. What we're finding in the last what I'm finding in the last 5 to 6 years is a general shift. You'll see the OWASP top 10 change last year from what it was before to see business logic and FLAC issues as the largest area of risk in applications. We're finding the vast majority of our pen tests now head towards in that direction. So they're looking at business logic flaws, authentication flaws, escalation privileges, cross-tenant compromise in multi-tenant applications, that kind of thing. And there's no automated tool that can do that. No. And there never will be. AI, as I said, might get to the point where 5% of a test you can say, okay, I understand that, but you'll always need to give that to a researcher. So somebody who's got the intuition, experience and knowledge of different applications and different ways to compromise. 194, that's outdated. As I said, 220 to 230. 1,553 vulnerabilities from pen tests last year across the board. Now, I won't tell you how many of those were critical. It wasn't a lot. I'll be giving away trade secrets if I did. We tend to find we've got a lot of vulnerabilities that are what we call low-level vulnerabilities. So those are vulnerabilities that are so esoteric and so difficult to exploit that they represent an incredibly niche case scenario. Depending on the risk appetite for the application, healthcare for instance, we'd probably want to fix those. For other industries, we're not particularly interested. They're nuisance value only. They're not chainable, so you can't use that as a foothold to then escalate your privileges somewhere in the application, for instance. We do have the odd critical. They tend to be with applications that we haven't pen tested for a long while, or acquisitions, and it tends not to be their marquee app. It tends to be the stuff they use to support it. Which is fine if it's internal, we can fix those. And it's a nightmare if you've got, for instance, an application that has an admin port. or even worse, the admin functionality is built in and reachable within the application depending on your credential. So having pen tests is incredibly important for us.
So in the CVSS score, the base CVS score, are you modifying that CVS score based on your knowledge?
I'll come on to that. I'll mention something at the end that I'll use to tie it all together. And yes, but we don't do it ourselves. And I'll come on to why later on. So, improper access controls and injection, usually cross-site scripting. So SQL injection by default. Usually cross-site scripting. Again, as I say, if we find an access control issue in an application, it tends to be because security wasn't thought of correctly when it was first built and implemented. And the cross-site scripting is just because they don't sanitize input properly in areas. Pen tests are really good at finding that. Cross-site scripting, as I say, we can fire something here. It can make a really good job of finding other instances. But if I find an application where access control isn't implemented correctly and it's endemic throughout the application, that's a nightmare because the amount of work involved from a pen tester to do that in a large application is huge. So what we tend to find is, if we do find it in an application, we find the most serious area, so that most at-risk function calls, for instance, and we'll fix those, and then we'll get the team to dedicate to sometimes even 4 sprints to going through the rest of the code base and finding where else it's an issue. And then afterwards, we get it revalidated with another pen test. That's
Shit.
I'll come on to that in a second. Yes, dynamic application security testing. I don't think we've got anyone from Appsec in the room, have we? Okay. I'm not going to badmouth them because they are great. Every other DAST tool I've ever used is crap. So DAST is dynamic application security testing. It's designed to get rid of the grunt work that a pen tester does. So when a pen tester is going through an application, they're using Burp or another proxy, generally Burp, they know what they're doing, and they're generating a load of requests, they're seeing where something might be an issue, and then they're going through the rest of the code or finding other areas of the application where they might be able to exploit that. Appsec does a good job, so DAST now does a good job, I'd say reasonable job, of finding other areas. So it's doing that sort of next level up from static application security testing where it's just looking at the code and it's trying to guess what might happen as a result of individual web calls or URLs visited, for instance. Uses code and a rules engine or heuristics to probe for common issues. Again, cross-site scripting, cross-site request forgery, SSRF, that kind of stuff. As I said, does a really good job of it. Still in its infancy as a technology, and to your point, little more than snake oil until recently. Right? So you'll be familiar with this if you've used it in the past. It takes a massive amount of massaging to get anything useful out of it. It's not a tool you can give to developers. If I gave this to a developer and asked them to manage it themselves, within 2 days they'd be laughing me out of the room. It's impossible. The amount of effort that you need to put into it makes it just a pointless endeavour. So what we use it for is because we use Appsec, as I say, as a supplier. They supply the platform for us. They also do some of our pen tests. So what we do is give them a scan, or it's their tool, so they'll scan the application for us, sort of 2 or 3 days ahead of the test, and then use that potentially as a reference. They know what they're doing, so they can configure a scan. Believe me, sometimes even getting the authentication working in a DAST tool is nigh on impossible. A developer, in conjunction with a tester, will understand that process better than I ever could. So we don't use this, we don't live and die by it, but we use it as a supporting tool for our pen test done by Appsec. As I said, starting to use complementary additional pen tests. And go on.
Just one point on the DAST tool. No DAST tool that I found on the market can handle multi-factor.
Yes.
So they tell you to turn it off.
Yes.
So if you've implemented MFA, they tell you to turn it off. So I just find it less than useless tool.
Well, I mean, so Appsec does a reasonably depending on the MFA that you're using. So if you're using anything esoteric, it's got no chance. But if you're using off-the-shelf sort of, I don't know, can't think of the framework. If you're using OAuth, it does a reasonably good job of that. Needs some massaging, and if you've got any instances where you can't massage the MFA process on an individual level, so if you've got basically everybody in the account requires MFA and it has to be set up in a certain way, then yeah, it's not going to do that. But if you've got the luxury of having a dev environment where you turn MFA on, because for every pen test where we put multi-factor authentication in the application, we want to test that flow as well. So we don't just test the underlying app. If you've got the luxury of being able to get an application where you can turn that on an individual user and massage it, it does a really good job. But yes, you're right, it's a massive pain. You're not an Appsec user, are you?
No.
What have you
I am
used?
a very big fan of IS.
No.
I'm actually coming on to that.
No.
Oh.
Which I'm not going to cover it. I just literally didn't have the time. So the amount of stuff that I've got to try and smash through, even the speed that I talk, there's some stuff in there and stuff in. So bug bounty. Can't believe there's no independent security in your house. No hackers. No. So bug bounties. Yes, excellent.
That's what I do legally.
Okay, yeah, brilliant. So via a bug bounty program.
Authorization.
Via a bug bounty program.
Yeah.
So you'll be aware of like HackerOne. Their marketing is absolutely fantastic. It's brilliant. They're not the best bug bounty program out there. I'll tell you that now. They are good. They've got a huge number of researchers, but being a platform of that size, you attract a lot of flies as well. So you're not just attracting people who are good at it, you're also attracting a lot of chances. When you get to the good researchers and you give your application to good researchers, it's great. When you don't, you get a lot of nonsense. You have to wait for it. I won't tell you the platform that we used when we did our POV. We haven't actually implemented it, and I'll come on to that in a second. But what if you could crowdsource your pen tests? I've got my pen testers. They're fantastic, but they're bloody expensive. Sorry, Nick. It's true. They're expensive. It's not a cheap undertaking. So my pen test budget last year was 670k. This year is likely to be just under $1 million. And that's just for pen tests. So the more pen testing I do, the more money we spend. If I can outsource that to somebody, and somebody has access to the application 24/7, as opposed to in a small time box window, I'm much more likely to get results. So thousands of security researchers doing your work for you in a safe, controlled manner. So whilst you might not tell them exactly what they're doing and focus the test in a certain area, you can control what they do. And so you rely on your bug bounty account manager to help you with that. So we're both massive proponents of bug bounty programs, myself and Kane. So we carried out a POV. We exhausted the bounty pot for a 10-day trial inside 36 hours. And that was with 3 applications. It's a massive boon for public sign-up applications. Applications where you require an account and somebody to give you an account, they're a lot more difficult to compromise by their very nature. Any application where you allow somebody to sign up publicly, a restaurant booking application, for instance, they're invaluable. That 36 hours included 2 criticals that we hadn't found before. Not on previous 10 pen tests, I hasten to add, because they were in areas of the app that hadn't been pen tested. But that gives you an idea. In 36 hours, we found 2 critical vulnerabilities that we wanted to fix, and that we weren't aware of before. How long ago? Not long. Brilliant. Told you, I'll speak quickly, but I'll waffle as well. So shift left. What is shift left? So it's built around 5 main domains. So design, implementation, verification, operations, and governance. And don't worry about remembering those, because I've got a crack into the slide next that shows you it. But it basically describes our holistic, I love that word, ground-up approach to Appsec and the Access Group. So it describes what we do to embed secure development practices in every developer, every application, every platform we've got. It's built around the OWASP Foundation. So the OWASP SAM, so it's Security Application Maturity Model. I think I've got that right. Conscious that we're on time, let's move on. So it's built around the SAM model, which basically describes application security governance and development. And it includes training, fundamental and more advanced. So every developer we've got, and everybody that's involved in the development process, so DevOps, even account managers, product managers, everybody goes through our security first training. So we've got 18 specific modules that are developed in-house that we recorded, some of them done by our heads of division, some of them done by security subject matter experts, and it goes through the entire Appsec process, including threat modeling, which I'll touch on at the end, all of the tooling that we use, penetration testing, and DevOps, so secure DevOps, that kind of thing. And it governs not only the way we secure the software, but also the way we develop it. So that's imperative. That's what we tell people. If they take one thing away from shift left, it's not just how we secure it when it's out there, it's how we develop it. So coming on to the cool slide. Probably I might have one more cool slide than just text. So OWASPM v2, so it's the second version of the OWASPM methodology. And as I said, 5 main domains. So the first one is design. So threat assessments, what we do to make sure we've got secure architecture. So we have what we call a secure reference architecture. So to your point earlier about what dev technologies we use, as I said, we're mainly a .NET house, so our secure reference architecture is based around that. We've got some applications that we can't fit into it, but other applications we try and at least give them a flavour of what we do if we were developing an application from scratch. And then privacy by design and by default. We've got a fantastic data privacy officer. She is a pain in the arse like every single data privacy officer. And that's literally part of the job description. She makes sure that everything that we do for data privacy is embedded right at the heart of everything we do. Implementation. So this is secure build and deployment. So this is where you're talking about pipelines and stuff. So if we've got a DevOps process, DevSecOps process, we make sure that we embed our tool in there, for instance. So if we've got an application that uses a load of different third-party libraries, if we can, and we're moving more and more towards this as applications mature, we try and embed that SCA process in the pipeline. So if, for instance, we find a critical vulnerability, we can fail the build. That doesn't happen very often. It does happen in a few apps. We can fail the build, or at the very least, we can alert it and say, you need to fix this now. Sometimes we do fail builds and don't release as a result. So, for instance, if someone's stupid enough to develop something and put an old version of Log4j in there, red flag, and deploy. The more we can be mature on that, the better we are from a security perspective. Verification, so architectural assessment and requirements-driven testing. So this is where we verify what we do. So we chuck something into a pipeline, we test it, and then we verify it. So before we release it, we say, okay, have we met this criteria? How are we confident that there's nothing there that's going to kill us? Operations, so environment management, incident management, operation enablement. So this is where CSPM sits. So cloud security posture management, for instance, for scaling out. And then governance, strategy and metrics, education and guidance, and policy and compliance.
How much time does it take to
Sorry?
How much time does the team get spent for testing?
It depends on the application. So some apps we've got, the sprint process is pretty quick. So we've got some apps that you deploy multiple times a day. We've got some applications that are monolithic that take a lot longer, and they may get a little bit more time. So it's crucial, obviously, to make sure that your processes are better for teams that are challenged because their build processes are so swift. So because their release cadences are really, really, really frequent, this is really important there. If you've got an application that allows you the luxury of having a bit more time between sprints, then obviously they've got a little bit more time by definition to test. And then governance, so it's the boring stuff. That is where Sorry? It is the important bit. As I tell everybody when their eyes glaze over as I start talking about rate logs. It's the important bit because for an organisation of our size, you can't know everything yourself. It's impossible. So having metrics that you use, that you live and die by, is massively important to an organisation of our size.
So is your CISO responsible for this? Or is it a different one?
Ultimately, yes. Ultimately. So until recently, we didn't have a CISO. We had a CTO, and they did everything. And we've now got a CISO, and ultimately, they're responsible for this. He's relatively new in the job, and so we've tried to sort of shelter him from the boring stuff and just give him things that he needs to focus on now. But yes, ultimately, the CISO is responsible. And in most organisations, the CISO would be ultimately responsible. Even for an organisation that might have an individual head of each division that does what I do, has the luxury of having 12 of me, for instance, there'd still be a CISO that's ultimately responsible for a board. And if you're a PLC, it's PLC. And then risk management, like I said, do you know that's boring? That's even more boring. But that's where I live and die. So charts, I'll come onto a platform in a minute, but I keep training. Charts, spreadsheets, graphs, that kind of thing. So how the tooling fits into the SSDLC, I'll smash through this quickly because I know the sword of Damocles is hovering over me. So requirement analysis right at the outset. We've got loads of different tools you'll see at each stage of our SSDLC. Annoyingly, there aren't 5, so it doesn't match quite. There are 6. It's a real pain. But if you can imagine conceptually, it's a wheel, just like the previous one was. I can give the slides after. I might have to redact them, but there we go. So that icon there, the shield, is our security first program. And then we've got a load of other stuff. So obviously we use the OWASP methodology to underpin everything that we do. That, you know what that is, icon is our program management software. So that's called Target Process. So that's where I have my RAID log. 6,000 items or something stupid. Then we come on to Secure by Design. So this is where we try and embed things into developers so it's developed securely. We are a heavy user of Pluralsight as our learning platform. One of our courses, our course pathways, learning the OWASP top 10. I'm conscious that I keep polishing off the OWASP top 10. Sounds good for you, right? But one of our pathways is 10 modules in learning the OWASP top 10. Every developer takes that. Everybody using DevOps, architecture, etc. We also use LinkedIn Learning for a couple of things. And then we've got our own threat modeling processes as well. I'll touch on those later. That's what I've been trading the entire time, ARM code. I'll come on to that in another slide, but that's when we're putting everything together. Notice it's also there. I could also argue it's there as well. It's everywhere. And then, again, our tooling. So mainly SonarQube, Appsec that we use for DAS. Then testing readiness, so basically verification. Pen test, our independent tester that I manage his time. That's brilliant. That is still independent, but I manage his time. So I don't have to go begging pen tests for a resource. Sorry. And then monitoring and alerting. So what we do with Cloudflare, so Prisma, Cortex as well. So we put Cortex on our infrastructure. So where we've got traditional infrastructure, not services, where we've got servers, for instance, we put Cortex on there, which is an IPS. So it's Palo Alto's antivirus client, anti-malware client, for want of a better term. And that feeds into that as well, along with everything else. And then finally, continuous review and improvement. So anybody who's used the bug bounty program probably knows who they are, but I won't tell you because we didn't actually go there because we haven't signed a contract yet. But that's the bug bounty pod we were looking at. Armor code again, and then, as I say, our reference management tools. Tying it all together, this is the important one. So, everybody knows what that is, right? You remember the episode. I'll just put this for the rest of the fire. That's exactly what I was doing for the first 3 or 4 months of Access. It was impossible to keep on top of everything. They did a really good job of onboarding me. A massive data dump. Obviously, you come from an organisation where you've had maybe 15 applications to manage to an organisation where you've got 200. It can be overwhelming just to the scale of it. They did a really good job of giving me all the information that I needed. Attempting to get that information into anything like a readable, and more importantly, a reportable form was impossible. If you think about the reference tools that we've got alone, so the SCA platform, 32 to 35,000 individual libraries in there. The SaaS platform, God knows how many code bugs and smells there are in that. DAS, now we feed that into it as well. CSPM with 130 different cloud tenants across AWS, Amazon, OG CloudJet. Trying to tie all that in together and to give an overall risk from a product perspective, a division perspective, and then from an organisation perspective, impossible. So, this is an example of the kind of stuff you have to tie together. So just 3 different tools. So that is our SCA platform. Great, that's brilliant. How am I going to report on that for 200 apps? I can't. That's our SonarQube platform. Really good from an individual perspective of how an application looks or across a suite of applications. How am I getting metrics out of that to give to board? And then finally, CSPM, so Prisma. That looks really good. What does that tell me about these without drilling into it? Nothing. So it's impossible to keep on top of this at anything other than fiddling. And you're literally fiddling while Rome burns because you can't tell what's actually important. You spend your entire life going through statistics in platforms. So, another buzzword that changes every 6 months, like CSPM, ASPM, Application Security Posture Management. So this ties all of our platforms together. So all of our technical platforms, we ingest all of our pen test results into it. Our threat modeling is in there as well, where we do secret scanning, that's in there too. So it allows us to see the wood for the trees, most importantly. It allows me to say, right, I've got this division that's got 10 products. Of those 10 products, 2 are marquee products that we sell. 3 of them are market penetration products where we have the offering, but we just got it there for market share. We're transitioning people away from it onto another platform eventually, but we're not mothballing the platform. 5 of those products are in various stages of deprecation. So we support them, but they're on long-term support, life support basically until we turn the plug off in various forms. They're not as important as the marquee apps. The marquee apps are 100%. No matter what anyone will tell you about, you need to be careful about everything that you've got because it's all as important as everything else. It isn't. It might be to me, but it ain't to the board. The board don't care. All the board will care about is your marquee applications and whether or not they're at risk. So this does a really good job. I'll come on to it and show you in a sec. Does a really good job of tying all that information together, giving me that product, division, and organisation risk profile. And most importantly, let's just run with a team of 2 people. So if you find most metrics, they'd say that an Appsec engineer should support 200 to 250 devs. We've got nearly 2,000 devs and there are 2 of us. So just do the maths alone on that. The headcount increase and salary costs, because, I don't know the fortune, but we ain't cheap. The salary costs alone in getting 8 more people to do my job are immense. And this pays for itself 10 times over. So let's use an example of an outdated library. So there's a new library vulnerability. It's raised by a reference to Mend. So Mend sees something that's out in the wild. It says, this one, take Log4j for an example. So this has now been marked as vulnerable, and there's an exploit for it, and the CVSS exists. So that would be raised by scanning a pipeline or by repo integration. So where we've got the integration with a repo and the more modern stuff, that's brilliant because it integrates directly with the repository. If not, then we use pipeline scans, which are a bit more manual. That's then picked up by Armor Code, our SPM platform. And integration with, and this is really, really key for us, so integration with the ADO board. We're almost exclusively ADO now because we're an Azure house primarily. We do still have some Jira up around Anson, Team City, somewhere in Australia. But we're moving towards ADO more and more. And the integration we've got with Armor Code directly picks that issue up and raises a ticket directly into the ADO board. I can't tell you how good that is because asking developers to use another platform to manage their ticketing when they already use that platform for the rest of the ticketing, pointless. And you just wouldn't get buy-in for it. Doing this automatically means we don't have to do that manual process as well. So it's fantastic for that. So we trigger an OLA. So basically, something happens, depending on the severity, we say we want this fixed now, we want it fixed within a month, we want it fixed within 3 months. And then the team fixes that, triages that. The pipeline is rerun for where we've got manual pipelines, repo integration picks it up automatically. So when the latest version is deployed, the vulnerable library's been updated. There's no more vulnerabilities in that version. There are probably new vulnerabilities in the new version, but it then reports that and then closes that issue as well. So there's also a hitch process, if you like. So just because we integrate everything, we try and do everything automatically. One size doesn't fit all. So there are plenty of occasions where a team might say, okay, well, the tool says that this is an issue, but it isn't because we've got another mitigation that the tool isn't aware of. And then they can raise that exception process with us. So we still get exceptions raised with us pretty regularly, but we're starting to see less and less of those as the process matures. But we still do give teams the opportunity to say, I don't really think that's the case. Not having an argument yet either, which is good. So what does this result in? That. So bubble charts. So you see the size of the circle, that's the size of the division, the size of the products. And this circle's at the top, so this trend line here is what we had across divisions. So we've got some divisions that are larger than others, but you'll see that they all had a specific number of vulnerabilities and within four months of using Armor Code across the board, every division is now down, including those bad boys. So we've got some divisions now that have no high or critical risks. I can't tell you how amazing that is as an Appsec guy to see that zero. Admittedly, they didn't come from a massive place to start with, but some of those vulnerabilities would have been critical as well. So to see those down to zero in 4 months is incredible. And to be able to present that to board, to show that what we're doing makes a difference, it's of paramount importance to me. So, last thing, I promise, threat modelling, and it's very brief because I didn't go into a lot of detail on it. So, anybody come across threat modelling before? So at least some of you have done the boring courses. So threat modelling is really dry. It's a dry subject by default. If you're the sort of person who likes DFDs, that kind of thing, then threat modelling is more your thing. Most of our devs aren't. Most of our devs want cool stuff and toys to play with. But we do ask for every application we've got where it's possible to do a threat model. So we're currently using the Microsoft threat modelling tool because it's free. It does a reasonably good job. It gives you a diagram. It's lacking in support. I think it's one of those things that Microsoft developed as an internal tool, released to the wider world, and never really supported it beyond saying, oh, this is great, off you go with it. So the lack of template in stuff available for it means it's limited of use. But if you just use it to give yourself a sort of functional organisational overview of your application, it does a reasonably good job of that. So we use Stride and Dread. So Stride to model and Dread to model risk. As I said, I told you it was dry. There's nothing drier than something that uses 5-letter acronyms, right? So it uses Stride and Dread. They're basically the way that you model your application, so making sure that you're doing it on an iterative, repeatable process, and Dread to measure the risk level you're at. It sounds great, but it has its limitations. So we recently finished a POC for an SSDL. Oh, God, that's annoying. Last slide. SSDLC. For an SSDLC tool, ubiquitous software development lifecycle tool, which improves our threat modelling capabilities. We haven't purchased it yet, we're just on the verge of doing it. And it doesn't just do threat modelling, so it does full threat stack analysis of your application. It maps technologies, architectures, and applications to a list of known threats and concerns. That list is constantly updated. So it's not just your authentication model might be at risk because of this. So it might say, for instance, you don't have MFA, that's a risk. But you also might say, to go into a bit more depth, your MFA process uses this, and this is at risk because this new vulnerability has been announced, that kind of thing. So you'll be aware of the recent OAuth vulnerability, which allowed third parties via support to compromise a couple of major players' infrastructures. So the SSDLC tool we're looking at will do a much better job of teasing that out. So it's not just some amorphous diagram that says your authentication process is looking at. Make sure this is secure. And it will also soon be integrated with Armor Code, so our ASPM platform. And then that will truly give us that soup to nuts sort of process, what the application looks like right at its source, what it looks like through the DevStack process, what it looks like with tooling, what it looks like for release management, and then finally what it's like for testing and reporting the outside work. How's that?
That's good.
A little bit over?
A little bit over.
Sorry. I knew I should have got that time checked by someone.
We'll forego the Q&A, though. If people have questions, see Stuart in the break. So thank you very much, Stuart.
All right.